Good afternoon, everybody. A lot of people. Okay. So, this talk is about exploit key crawling. Make easy. The first name was againt something framework because it didn't exist. And we wanted some original name, but it was unpronounceable, so we changed it for something more easy, like exploit key crawler framework. So we will present some project we still at the POC stage. If you have some technical question, ask Sebastian. If you don't understand the joke, ask me. So first, who are we? I'm Guillaume. It's Sebastian. We are two curious guys working for a small French company called Sequoia. We have both some experience in network analysis. We love pickup and Python. Well, especially Sebastian. I like Perl, but that's quite an internal troll between us. And so we are French. So if you don't understand my English, just raise the hand. I will try to speak slower. If you have questions, speak slow, very slow, or speak French, because I'm quite good with French. And no, it's not crazy. So why? So let's not be a little more serious now. So why study exploit kits? First, what's an exploit kit? I guess everybody knows what an exploit kit is, but it was quite mandatory to have some slide about it. So it's some kind of malicious piece of software, usually installed on some server being compromised, and used to conduct drive-by attacks. And currently, it's one of the most dangerous threats when surfing on the web, because when you have some malware spreading by mail, you have some user to click on the attached link, file. Okay, I know everybody clicks, but some does not. And while if you attack some vulnerability in the browser, it's more easier because you just have to surf on a website to get infected with some kind of malware like Zeus. Okay, I got the same here, so I don't have to turn my head. So it's used to infect machine with malware like Zeus, with Citadel, Bunker, but also during APT attacks. This was buzzword. And I don't know why CryptoLocker is not yet distributed widely with exploit kit. So if CryptoLocker developers are listening, just an idea. Okay, so here is a map of some of the more common exploit kits 2 years ago, 1 year ago. Yes, some months ago. And we just focus on the black hole. It's a little ship on the left for you. And Phoenix on the right. Because they are embedding the most vulnerabilities, target the most browsing. So black hole is quite known by some people here more than I know myself. Was born or created in 2010 by someone called Punch or Orlum. We will know in the next day his real name, I think. And it's one of the most popular exploit kits ever distributed and created, using PHP, HTML, JavaScript, embedding exploit for Java, PDF, Flash, Internet Explorer, Windows, and exploit being updated on a daily basis. So very accurate, very active. Use of advanced authentication techniques, just for PDF and JS, and URL spread by spam campaign, meaning you receive a mail with a link and you click on the link and you are infected. And it was distributed with a software as a service business model. It was, because unfortunately for him, the Phoenix exploit kit offer was awarded in April this year and Punch in October. So just a little pause now. If you guys could please stop arresting this guy. Our project will be able to live because our exploited framework was based for black hole. So now it's quite useless. And for us, it's months of development. So if you could just stop arresting this guy until the next DEFCON, for example, Sebastian and I could submit this paper on a lot of conf now. So the goal of exploit kit crawler is just to gather some intelligence about the exploit kits themselves. Understand what kind of URL diffusion method are used, spam or something like that, or by Twitter or by Facebook, this kind of thing, how the links are spread. Understand the techniques used to obfuscate the code, look for similarities between some same exploits shared by different exploit kits, and mapping the targets and the payloads, meaning what this kind of exploit kit is targeting to, this kind of user, this kind of software, this kind of OS, and at least identifying exploit kit author. Well, no, not really. So how to find exploit kit? The easy way with the typo is to browse some websites like malware domain list and just get the list, pick a URL, hope it's still active, hope that not someone like malware must die, or just cut the domain. Run a VM embedding some vulnerable software like Internet Explorer, for example. Open the URL from the VM and just see what happens if something happens. So it's quite easy. So why do we need something very complicated? It's because sometimes failure can happen. First, the URL can be offline yet. So stop here and come back. Yeah. Second, it triggers only if the request is coming from a specific page. You have to have the right referrer to get infected, or with some valid cookies. Some only triggers once. If you come twice from the same IP, same machine, you won't be get infected. So if you don't have the right vulnerable browser or the right plugins, and you came back later after having installed this software, you won't get distributed. You won't have any exploit distributed again. You also sometimes have to have the right user agent or the right IP for some exploit kit that targets some geographically geographic zone, and some also use kind of anti-robot and anti-spy techniques. Well, you can fail at every stage. So wget or curl won't fit. That's where automating browsing came from. So what do we need to crawl automatically infected page? We can just hire some students and pay them to click on every page they see, but in its place, we don't have money in place. So the simplest thing was to develop an automate. So we have to find malicious web pages, to browse these pages with vulnerable browsers, avoid the failure we see previously, running exploit or having the exploit running, and then hopefully a good coder. So to find this malicious URL, we can use two ways. First, we can target the URLs that spread with spam. So we can use spam boxes, extract the good candidate URLs from the mail received on the spam box, and feed a spider. Second, for the malicious URL spread with through web pages and not through mails, we can just try to spam advertise. We can also use search engines with some specific keywords we know that will send some SEO web pages, embedding this kind of link to this kind of web pages. We can also base our research on Twitter trends, because Very usually, the bad guys use Twitter trends to spread this URL, or same for Facebook. And the third is to just submit online. So another way is to take the log of the proxy and to feed the proxy, the spider with the register, the logged URLs, but we have some time delay and maybe not very accurate. So next step is browsing all this malicious URL. But what if some website requires an authentication like login, password? How to preserve the right HTTP referent cookies, and how to know what specific browsers are vulnerable to this kind of exploit, and what about geolocation? So for that, once we have that, we have to have a vulnerable browser, but we want to know what kind of malware is run or what kind of malware is sent when exploited. In some cases, it's just we have some the same pages distributing different kind of malware. For example, we can have a Trojan horse like this, or just a rogue antivirus asking to send some money to the Gendarmerie Nationale, for example. So, why did Sebastian develop exploit Krawler? Because the first sentence is a joke already done. So it's not exactly a spider. We don't launch a search engine like it's not yet another Google bot spidering all the pages. It's based on Selenium, who drive browsers fed with the previously seen source of URLs. It's not exactly a sandbox. It's a collection of VMs of different types. And it's not exactly a proxy at all, but we are collecting all the objects sent by the infected web pages, like the files, the headers, the cookies. And we have some SSL minus the browser capabilities in order to detect objects sent through HTTPS, for example. So basically, it's an exploit Krawler. So how do we do that? So first, with Python, with Selenium to drive some VM and some browser. Virtual machines, currently just the VirtualBox, but we can also use VMware or QEMU, for example. On a proxy with a small HTTP, HTTPS proxy with man in the middle feature, and some MongoDB for data storage. But so, one picture worth 1,000 words. So how it looks for. On your left, in the bottom, with the number 1, we have the list of URLs we want to feed the core engines with. It can be fed with some file with URLs. We can feed it with logs. We can feed it with, for example, some scenario. A scenario will be, for example, open Twitter, log to this Twitter accounts, perform this kind of search for this kind of words, or look for the 10 Twitter trends of the day, then look for all tweets relating to these Twitter trends, and collect URLs. The same with Google, or same with Facebook, in order to just fit the bottom 3. The little point 2, the little wheel. It's the Selenium scheduler or dispatcher. It's the same for me. It's something that takes the URL from 1 and sends them to 3. Call it dispatcher, scheduler, what you want. At this point, you can select the VM in the 3 box who will browse the URL. That leads us to the box number 3, with a Selenium-driven browser in VM. And you can have, as we already said, different kind of VM with different kind of processes, of operating systems, or different kind of browsers. You can also have some mobile devices if you want. And from the two, the dispatcher will say to the VM, okay, just take these URLs and run it with the VM 1, 2, 3, 4, and so on. Then from there, the URLs will be just open, running through a proxy on point 4. On this proxy, all the flow coming up and down are just stored on database 6. And on the box number 5, we have some distributed proxy all around the world. Okay, that's an ideal condition. We don't have this yet, so don't worry. And these proxies are responsible for browsing the same page from different locations with different geographic zone IP. No, that's not easy. With different IP from different geographic zone. It's more correct. And then if some exploits are found, all goes down by the interest of having virtual machine here is that we don't have to rewrite all the browser intelligence, just like it's done with a tool called SUG, coded by Angelo Dell'Aria, with an on-a-pot client for web. So we don't care about having to rewrite all the browser intelligence because we have real browser. And we don't also care about anti-VM technique used by malware because all the VM are just there to act as a trigger. Yes, a trigger. Even if the VM is not infected, we don't care if the VM is not infected really. We just want to catch what goes on and down, and the most important part for us is to store it in the 6 database. So even if the malware don't run on the VM, it's not a problem for us. If it runs, it's better. And so we have the catch APT layer on the bottom of the box 3 with some code developed to monitor all VM behavior from the host and not from the guest. So that's what Sebastian will detail later. And once we have all this big database, we just apply some filtering on it, and we display it. Actually, we just have this, not yet the other part. But the goal is to have a large collection of objects and logs, and then to analyze these logs with something like Splunk or Malcolm. Okay, so it's just what I say, so I won't repeat it. Okay, but there is a lot of stuff still under coding. If we come back to the main picture, we have the first component, the second one, the third one, the fourth, not all the 5, and the 6. The 5 is optional, in fact. We can just have a direct connection from 4 to 6. No, 4 to internet. Oh, and demo.
So for the demo, I launched one instance of CatchAPT. CatchAPT, it's a framework like an EPOT to detect the anomaly behavior in a virtual machine. How to detect an anomaly behavior? I dump the RAM with the host, and I pass the RAM, and I detect new process created during the execution of the different browser to go to the web page. the first step, I make an image of memory with a different process, and I store in Redis database. Why Redis database? Because all is very fast, and all is in RAM, so it's very quickly. The second one, to parse the memory, I use volatility, but volatility is very slowly. So to resolve this problem, I make a RAM disk, and I execute volatility in a RAM disk, and all dump of memory is made on the RAM disk. So it's all on RAM, and now it's very fast. For the demo, to be clear, we have one instance of CatchGPT, and we have selected one operating system, Windows XP, and all browser on this operating system. But you can execute different operating system in the same time, and on a geographic place, because all the framework is south to launch command very simple in between Python, the virtualization, and Selenium was driven the different browser. So I launched Selenium to the different browser connect on the server Selenium. I make a snapshot. I resume the VM. I launch different browser. I simulate a black hole exploit kit with a social engineering toolkit. I make an image, and I store the RAM in the Redis. It's the part spend the most of time. And I make this operation one time, and after I go to the different web page is loaded in the web browser. I catch all the different objects in the web page. I record all information to executing context, and for example, Java, the process Java has created between the execution. I make different operation. I process MD5 sum, SSD sum. I disobfusc JavaScript to detect if I process entropy on JavaScript page to detect obfuscation, and it's different. So it's all exploit in Java is grabbed by the system. I think that's all. So it's a proof of concept. Today, we arrive to execute different, in parallel, different operating system and browser. You can choose, for example, one operating system, and I want just launch Internet Explorer or Chrome. Or you can choose Chrome and all operating system on different. So you can make different receipts to test different different way the web page, how the web page is loaded. For example, if you catch ActiveX exploit, you execute only Internet Explorer. It's, and we can drive browser, Android browser, because it exists Selenium Android browser, and we have different virtualization machine to store and to detect to launch on parallel. But today it's run correctly with VirtualBox, and we want to execute the same process in QEMU and VMware. The second part, it's a front end web like URL query, and to describe your scenario. If you want to test a trend topic on Twitter, or to make search on Facebook, or use Google Docs on a typical world, it's in the future it's really possible. We want to integrate VAT tools. VAT tools is a system to check the RAM and detect the page on RAM if this page is an executable or readable, because many malware transform the readable page in memory and executable page to execute the shell code. We want not automatic disobfuscation on JavaScript. On simple case, because if you have 3 or 4 eval in the following, it's a bit difficult to have an automate to disobfusc automatically. But the Blackhole V2, it's a very simple obfuscation. You have one eval, so you can override this method with Selenium when you load the page, and you have all the payload disobfuscate, and you can parse it to detect automatically the JavaScript test, version Java, version Adobe Reader, version Flash Player or Shockwave. So in Blackhole V2 it's very, very simple. And no, I don't. The last. And
so bubbling up output, in fact, it's a way to print the result not only in lines but with bubble. You will see that later.
The next presentation. The goal is to have a visualization of different parts, like what kind exploit are executed in a domain name or IP address, in which browser, browser version, and we have an OSINT tool framework with IP address or domain name to catch all information, to make a fingerprint of this typically exploit. For example, the author in a forum or something like that. But to have a distribution in geolocalization place, we need you to host our codes to execute on different places. For example, in US, in Japan, or in Australia, to make a botnet to crawl the different pages, to execute the malware, to trigger correctly the infection chains. Because, for example, Russian malware is launched on the Russia for only for few malware.
In fact, it's a box 5 here on the diagram.
So
we want to have some exit nodes distributed.
If you want to host our code, it's a good thing. And the second part, we release the code on open source on Bitbucket the beginning the next year. So if you want, if you have a question.
Did you try with sorry, Mark? Did you try with VPN? Because sometimes you can reach some VPN that give you some IP address from some other countries.
The problem, the VPN, yes, if it's my computer on VPS, but the VPN is difficult to make trust or VPN provider. So
we want to share the data, but with trusted people.
This question is for Sebastian. If there are so many eval in the JavaScript, it would be a very good idea if you use the client browser. For example, the Firefox has the plugin for the obfuscator.
Okay.
Then grab those data, it will be faster. Yes. Instead of reading it in the RAM.
That's a good point.
Yeah.
Other questions? Okay. Thank you.
Thanks.